Assalamualaikum and good evening to Madam. We are from Group 5. So today we present our assignment about application of differentiation. So this group consists of Nunasha Imelda binti Muhammad Nur Effendi Zulkarnain, which is myself. Next, Naomi Balkis binti Muhammad Aziz, dan Nur Hidayah binti Tuan Johari, and lastly Nur Alia Zayani binti Muhammad Zahini. So first we need to know what is the definition of differentiation. Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. This is a technique used to calculate the gradient of slope of a graph at different points. There are some applications on differentiation which are related rates, intervals of increasing and decreasing, first and second derivative test, graph and polynomial function, maximum and minimum value of a function, applied maximum and minimum problems, and lastly Rolle's theorem, or we call mean value theorem. In our group choose subtopic graph of polynomial to explain it more. What is graph of polynomial function? Basically, the graph of polynomial function displays graphs that have no breaks, where the curve with no breaks all continuous. As you can see in the picture, show that a graph, which is the arrow, show that the graph is continuous up, and other side is also to go up and continuously, and the second graph is go down, concave down continuously and concave up continuously. There are several main aspects of this type of graph that you can use to help put the curve together. We will be looking at finding the zero, or we call as the x-intercept, as well as the y-intercept of the graph. Another important concept is to know the largest possible number of turning points. This will help you be more accurate in the graph that you will draw.
The objective of our topic is to recognize characteristics of graph polynomial, to use factoring, to find zero of polynomial function, to identify zero and their multiplies, to determine at the end of behavior, to understand the relationship between degree and turning point, to do graph polynomial function, and the last one, to use intermediate value theorem.
Next is answer explanation. For the first question, is to find x-intercept and y-intercept. For the y-intercept, we can use the formula to find y-intercept is equal to x equal to 0. So substitute in the function for x is equal to 0. So we got answer y equal to 4. And for x-intercept, we substitute we use y equal to 0 and the function is equal to 0. So the x-intercept is 0. Okay. The second question is critical point. So how we can find a critical point is we have to differentiate the function, and for this question we got x to the power of 2 minus x minus 2 equal to 0. So we factorize and we got the critical values, which is x equal to 2 and negative 1. And to find the critical point, we have to substitute point x to the function. And now we got the critical point, which is 2 over 3 and negative 1, 31 over 6. Third question is to find the interval where the function increasing or decreasing, hence to find the relative extrema. First, we have to determine the interval where the function increasing or decreasing. So we use the same explanation, the same equation as to find the critical point. Once we got the critical point, we use to create a table like this. For first column is interval, second column is test values, and the third column is the sign, which is whether we want to determine which is increase and which is decreasing. Okay, so the answer is function increasing in the interval negative infinity, -1, and 2, and interval. And for the decreasing function in the interval -1, 2. So the relative extremum is -1, 31/6 is the maximum point, and 2/3 is the minimum point. The fourth question is to find the concave up or concave down for the function and the inflection point. So the first step is we have to differentiate 2 times, which is f double prime x. So we got 2x minus 1 equal to 0, and x equal to 1/2. So 1/2 is the inflection value. X is inflection value, which is 1/2. So how to determine the concave up and concave down? We can use the concavity test, which is using the table that I state here, and put the interval and test value, sign of f double prime x, and the sign of f double prime x is the answer to determine whether that interval is concave down or concave up. So to find the inflection point, once we got the inflection value, we used to substitute the inflection value, which is x, which is 1/2, into the original function, which is 1/3 x to the power of 3 minus 1/2 x to the power of 2 negative 2x plus 4. And the last answer we got x equal to 35/12. X equal to 35/12. So the last is inflection point is 1/2 for the x, and y we got 35/12. So the last question is to sketch the graph. So here how we sketch the graph for this function in this question. That's all from me.
Now we'll start with the problem statement, which is consider the function f(x) equals 1/3 x cubed minus 1/2 x squared minus 2x plus 4. First, we find the y-intercept and the x-intercept of x. Next, we find the critical points of fx, and afterwards find the interval where the function is increasing or decreasing, hence determine the relative extremum of fx, if there are any, of course, and find the interval where fx is concave up or concave down, hence determine the inflection point of fx, if there's any, and last but not least, sketch the graph of fx using the above information.
That's all from our group. Thank you.